This video is for those of you that have chosen to do a linear regression t-test. One of the first things you should have done before watching this video is watched the videos in choosing between qualitative and quantitative, and also how to select your sample, whether you were watching the sampling videos for an interview or how to design an experimental study. So the first thing you should include in your report or in your presentation is something just telling me why you chose this question, why you were interested in it in the first place, and describe in detail what type of sample you've chosen, which again, that first video will help you decide which one would be best for you, and how did you collect it to assure that that was going to be random. Now, once you've written your introduction and you've talked about that, we want to make sure we've chosen the right test. So for a linear regression t-test, you have chosen a quantitative variable where you are looking at some type of measurable outcome. In this practice one that we're going to go through, I'm going to be looking at is there an association between the time that you study for a test and what your outcome on the score is. So the hours that I'm studying is quantitative. I can measure that in hours, and the test score I can measure in points. So these are quantitative, and I'm looking for an association between those two. So I'm going to enter this into my document, and I'm going to label what my two variables are. So under C1 in this gray box, I'm going to include the hours that I studied as my variable here. And then under C2, we are going to label as our test score. And I'm going to take just a second to go through and type in all of my hours into that first column. And then under the score, I'm going to take a second and enter the test scores. Make sure that you type them in order so that the time and the score associated with each other are together. Okay. And once you have your data entered, what we want to do is look at some things that are going to tell us what's going on with this data set. And we're going to summarize these statistics. So steps 1 through 6 will tell you exactly what you need to push or type into MiniTab in order for this to work. I forgot to mention, I do encourage you to use MiniTab on this simply because MiniTab does everything for you. Any chart, any graph, any calculations that you need, MiniTab will do it for you, and you can transfer all of that into your Word document or your PowerPoint presentation, and you don't have to recreate anything. The calculator will do a linear regression t-test. You just have to transfer everything yourself because your calculator won't send it to Word. So that's why I encourage MiniTab. So the first thing I'm going to do, I've already done. Step 2, I'm going to graph this. So I'm going to go up here to the top. I'm going to click Graph. Step number 3 tells me to choose Scatter Plot. You want to look at a scatter plot with the regression line. So I'm going to choose with regression, and I'm going to click OK. Step number 4 tells you to click in box 1 for Y variables. And you're going to highlight your response variable. So you have to define that. Do you think hours that you study is predicting what your score is going to be, or do you think your score is predicting what the hours of studying you're going to be? So I think hours is my independent variable, and my response is going to be the score that I get on the test. So I'm going to choose C2 for score and hit select underneath. You'll see that pop up here. And then for step 5, you're going to click in box 1 for the X variables and highlight your independent variable, which is C1 hours. We're going to click select underneath that box, and then you can click OK. All right, and it's going to give you a scatter plot which contains the line of best fit, your linear regression line. And we can transfer this straight to our Word document so we do not have to recreate this ourselves. So if you right click in this gray area up here, you'll notice it gives you a couple of options. We can send this graph straight to Microsoft Word. We could send it straight to Microsoft PowerPoint. If you're I've never tried this really because I'm a Word girl. I don't really work in Google Docs. I usually type it up in Word and then just send it to Google Docs. You probably could copy the graph and paste it into Google Docs. You can try that. I'm just going to send mine to Microsoft Word, and you'll see that it's right there for me to use. I don't have to recreate anything. It's probably not going to put it in exactly where you want it, so you can drag it to whatever part of your report you want it in. And that part's done for you. Now, once you've done the graph, you want to talk with your audience about what this graph shows you. And once you finish those steps, you can look at the paragraph that I've provided for you. It has 2 stars beneath each little checklist that kind of tells you what do you need to talk about from this graph. So we use the acronym FODS here in Martinsville, where, well, I do anyway, where F stands for the form of your graph. So it looks like that this is pretty close to a linear association. The O stands for any outliers that I possibly see. I don't really see any here. It looks like everything falls pretty close to the line. There's nothing that's standing way out here or way out here. The D stands for the direction that the line is going in. It looks like this may have a positive relationship. So as the longer I study, the higher my test grade should be. And then the S stands for the strength of the correlation. This one looks like it's pretty strong. All of the points appear to be pretty close to this line of regression. I don't have a lot of scatter. There's not a lot of points that are way away from the line. So this one should be pretty strong. So what we want to do, since I do see this positive relationship, what I want to know, is this going to show me a true association between these 2 variables? And I'm going to need to run a test for that. I'm also going to need what's called a regression model for this, and steps 7 through 12 are going to show you how to get that. So in step 7, and I'm going to delete out of this graph. I don't need to save it. I've already put it into my document. So step 7, we're going to go to Stat, and we're going to choose Regression. We will then choose Regression again and choose Fit Regression Model. Step 8, we're going to click in the Responses box. We're going to highlight our response variable, which was score in this case, and hit Select. Then we're going to click for step 9 in the Continuous Predictors box. We're going to choose the independent variable, which was our hours, and then hit Select. Step number 10, we're going to hit the Graphs button. We're going to change the pull-down menu to Standardized. We're going to click on Individual Plots for step 11 and make sure that Residuals versus Fits is checked. And then we can hit OK and OK to get out of the boxes. And what that's going to give you is a residual plot. And basically what this is telling me is if I look at this scatter plot, how far away are these points from the line of regression. So this 0 line would model the line of regression, and this would tell me how far away each point is from that line, and whether it is above the line of regression or whether it is below the line of regression. So you'll see we have 3 points over here below the line of regression. Those are these 3 points. This tells me exactly how far away they are. And you can see that all the way across the graph. So again, we can right click that, send it straight to Word. We've got both of those graphs in there. And we just need to talk about the fact that in this starred paragraph right here, it has equal scatter. We have just as many points above as we do below. It's not thicker on one side than the other. If this has a pretty equal scatter all the way across, then this should be a good predictor line. It should be a good fit. Okay, so when we run the test to make sure that this does indeed have this positive correlation that we're seeing, or this association, we do have some conditions that we have to check. We have our straight condition, which means your scatter plot does appear roughly linear. We've already discussed that, it does. And then we do need to check that residuals plot, make sure there's equal scatter, no thickening. We've already checked that as well. So both of these conditions check out and we can continue. Now, to help support your analysis, to run your linear regression t-test, if you just X out of this, your test should have already been run for you when you did all that, and your p-value should already be on the screen beside the independent variable. Now, this tells you a lot. If you look at, you've got 3 different p-values right here, so you want to make sure that you're looking at the right one. We want the independent variable, which was the number of hours we were studying. So if you look right here beside hours, you've got a p-value of 0. Okay. Now you've got a lot of other stuff here too. You have some information about r squared. You could take the square root of that and it gives you the strength of your correlation. You have the regression equation right here that you could use to make predictions for certain values if you needed to. Since we are only looking for the test in this particular video, we're just going to use this p-value of 0. Now these tests can also be transferred into your document. If you just right click here and send that to Word, all of this information will go in there too. Where'd it go? Well, let's try that again. Let's try it on this part. There we go. That'll send it to Word as well, and you don't have to retype any of that. Okay. So when you get to, once you've done that p-value, you've got your equation of least squares right there for your prediction line. You want to first write a statement about whether the correlation coefficient supports your summary in part 1 and interpret the slope of the equation for your problem. So your correlation coefficient we're going to look at the R's for that. So your R squared is a 91.15%. So R is equal to 0.9115. I'm sorry, R squared is equal to 0.9115. So if you take the square root of that, that is going to give you just R, which is your correlation coefficient. All right, forgive me, I gotta pull my calculator out for this one. Okay, so if we do the square root of 0.9115, I get 0.9547. And remember, with correlation coefficients, the closer to 1 that is, because 1 is the perfect linear relationship, so the closer to 1 that is, the stronger my correlation. The closer to 0, the weaker my correlation. So this has a very strong correlation. I saw that in my graph. We talked about that earlier when we talked about how close the points were to the line. So this should be a very good predictor line. And we also need to talk about what the slope is in this situation and what that means as far as my data is concerned. So if we look at the regression equation, This is y equals 337.93 plus 19.92 hours. And the slope is going to be whatever the coefficient is on your independent variable. So the slope for this is 19.92. And what that means is for every 1 hour that I study, my test score should increase by 19.92 points. That's my prediction. So for every one independent variable that you are studying, the dependent variable should increase by whatever you have for your slope. Or if your slope is negative, then it should decrease by that amount. And once you've talked about your correlation coefficient and your slope, you want to make a conclusion. Now, the hypothesis, what we were trying to do in the beginning, my null hypothesis, I wanted to try to show that these two have an association. So in the beginning, I wanted to assume that there is no association between the two variables. And you want to spell out what those two variables are. I'm just trying to make this video a little shorter. All right, and then for your alternative hypothesis, we want to show that there is an association between the two variables. Okay, but you would type out an association between test score and number of hours that we study, okay? So since I got a p-value from this test, and we always want to link this conclusion to the p-value, and that p-value was 0 in this case. That 0 is less than 0.05, which is our standard alpha level that we usually run these tests at. And the reason I'm choosing 0.05 is because I'm doing this on a 95% confidence level. So I'm going to be 95% confident in whatever conclusion I come up with. This alpha level can be changed. We'll talk about that in the final video that you're going to watch. But for right now, we're going to stick to 0.05. Since 0 is less than 0.05, we are going to reject the null hypothesis, and we are going to conclude that there is evidence of whatever my alternative was. So there is evidence of an association between the two variables. So I would probably be pretty safe in saying that the more I study, the higher my test score is going to be. Okay. If you got a p-value that was greater than 0.05, you would fail to reject the null hypothesis. You would not have evidence that there was an association between those two variables. The final thing that you want to talk about is, now that I've made my conclusion, is there a chance that I've made errors on this? And explain what types of those it would be. Also, you may want to look to see if you changed your alpha level, would your argument be more convincing? And we'll talk about those two things in two separate videos. So make sure that you watch those two as well to wrap up this final paragraph. You can do a test for regression in your calculator if you chose not to use MiniTab. You would just go to Stat and edit a new list. If you have information in your calculator already, you would need to go up to the L's and hit clear, and then come back down and your information will be cleared. So in L1, I'm going to take a second to enter all of the independent variable values, which in my case was the hours of study. And then in L2, I'm going to enter what the test scores were for each one of those values. Okay, once you have your information entered, you can go to Stat, right arrow over to Test. You're going to scroll down to the linear regression t-test, which is letter F. And your L1 list should be in the X, your L2 should be in the Y. Your frequency is always 1. You'll need to tell them what alternative that you chose. You can show that you think that you just want to show there's an association would be not equal to. If you wanted to look at this and say, well, it looks like a pretty strong positive association, so I want to show that it's greater than 0, you could do that as well. I'm just going to do the not equal to, and then I'm going to calculate it. I'm not going to worry about the regression equation because I already have it. But so you get a p-value of 4.89 here, which doesn't make sense because probability can't be greater than 1. So we look over here and we see that we have an e to the -6 on the back, which is scientific notation for times 10 to the -6 power. So we need to move that decimal 6 places to the left, which is going to make this very, very close to 0, which matches the p-value that I got from the MiniTab output. So you would still use that p-value of 0 to make your conclusion, just like we did over here. You just can't transfer this stuff to Word, which is why I think MiniTab is just easier to use. So make sure that you do watch those final 2 paragraphs to wrap this up. And if you have any questions for me, let me know. You can email me or stop by my office. Those of you in Danville, you can email or stop by to talk to your teacher, your math teachers down there. So good luck.